You've likely heard about Docker, maybe even done some development. It's an empowering way to bring continuous to your DevOps workflows as containers resolve one of the key aspects of packaging our applications for deployment. But you may be wondering if you need to give up on the productivity you've become accustomed to with Visual Studio. Hi, I'm Steve Lasker. I'm a program manager in the Azure Developer Experiences team. I work in our container tooling experiences, and I wanted to share with you the container tooling in Visual Studio to help you be empowered and not feel daunted by this changing technology. When we look at the continuous workflows, we see containers and registries are a key concept. We start with what we call the inner loop, which is everything we do before we commit our code. From the beginning of your development cycle, you're building and running your code in containers. We pull the base images from a registry, either Docker Hub or perhaps a private corporate registry. As we're happy with our code, we commit it to a source code repository. The build system takes our code, a Docker file describes the build system, and builds the collection of images I need for deployment. The images are pushed to our private registry with the environment configurations extracted because we don't want to deploy those in the base image. When deployment happens, we pull the images and the environment information and push it out to various environments. In Azure, we have many different container hosting offerings, from Azure Container Service, which hosts the best-of-breed open source orchestrators like Kubernetes and Docker and DCOS, to Service Fabric, which can host guest containers, or Azure Batch, or Azure App Services for single container workloads that can scale. And Azure continues to expand its container hosts as containers are becoming the unit of deployment. But how do I achieve the inner loop goals? With Visual Studio 2017, we've worked hard to provide the productive Visual Studio experiences you've come to expect while maintaining the core Docker CLI experience. Visual Studio 2017 will scaffold the Docker assets you need to get started, but they become yours to iterate upon. If you have questions, simply look up the Docker docs. The best way to show this is to show you the experiences, so let's jump into the demo. So what we have here is Visual Studio 2017. I'm going to create an ASP.NET Core web application. We'll choose the web application template, and I have the option to enable Docker support right from the beginning, but we're going to add it after just to show you what we call the brownfield experience. We also have a link right here for you to install Docker for Windows, which is the Docker runtime, the host to run your containers in right here. Now you can install the beta or the stable channel. Either will work depending on what you're looking for. So we'll create that project. Visual Studio will create that template project, restore the NuGet packages. And now we have our project here, and this is just a standard project. Now, what you can do is take this and add Docker support. And what this will do is add the Docker files that I need to build my Docker image. You'll see here from Microsoft ASP.NET Core, this is that image that it's going to pull, in this case from Docker Hub. We have a build arg, we set the current working directory, and we expose port 80. This is an important thing here. First of all, this is telling anybody that's asking the container what's its default port, what it's going to run on. But you'll also notice if you've done .NET Core development that this might be 5000 if you're running locally. That was created because you might be running on IIS, and we wanted to make sure we didn't conflict with the local port. Here, because we're running in a container, we own the entire process, and we didn't want to bring workarounds into our container environment. We'll copy the source to the source, such as the published output, because we're building an optimized image. We're not trying to build an image we're going to restore in the container. We want to build an optimized runtime image that starts as fast as possible. And we'll set the entry point. Now, Docker files define how a project is going to be built into a container. It's the declarative way to say, build this image. A Docker Compose file is how I instance the image for a particular environment. And you'll see that we've provided that here as well. Let's get started. What we'll do is we'll spin this up, and what if you look down here is you'll see a bunch of Docker commands start to get built, including that Docker Compose command where we're going to merge the production image, the production YAML file, with this dev YAML file, which is what we use to load the debugger and do the volume mounting for your source code, as well as turn on the file system watcher. So if I go to the About page, and as a Visual Studio developer, I expect to be able to make changes just as if I was running locally. And as soon as I save that, I can refresh my page and I can see that change. Now that's key here. It's just what you'd expect. There's what the expectation from Visual Studio. However, because I'm running in a container, I'm running an entirely different process here. And I could see it running right here. That's a little more complicated, but we've made that experience natural for you. Now, that's a single container, and I'll show debugging here in a minute. When I'm working with Docker, I more than likely want to do some kind of microservices-like architecture. I want to run multiple containers at the same time. So what I can do is say, add, new project. We'll again choose ASP.NET Core. I'll make this an API project. We'll make it a web API, and in this case, I'm actually going to add the Docker support on Create New Project. Now what we'll see is if we look at that compose file again, we're now going to see the web front end and our API container are defined right here in this compose project. And this is our startup project. Now to make this a little more interesting, let me just copy some content into here. And we'll copy some content from the API project. And we'll show what this is in a moment here. So what we've done is we've set up an API call from the web front end to our API container. And let's just run this actually, and we'll set some breakpoints and take a look at it. So what we're going to do now is Visual Studio, based on the startup project of our compose, is going to start up both containers. It's going to use the additional configuration information for VS Debug, the stuff that's unique to the VS environment, and I'll merge that in, and it will bring in the debugger for both of them. So now, when I click on our little API thing here, and we can see we have a little magic 8-ball set up, and you notice it says your answer. And if I click submit, we'll see those change multiple times. And of course, the magic about magic 8-ball is it doesn't matter what the question is. But if I wanted to see how that was working, if I go over to our front end, and I go to the controllers here, I can set a breakpoint right here. Well, I'll set it here for getting a new HTTP client. And then I'll come over to our Magic 8-Ball controller up here. And now, as I click Submit, you'll see I'm in the web project. That's my breakpoint, right? And I can step over and I can see all the normal information I'd expect from my rich debugger. And if I say continue, because the next breakpoint is set in my API controller, notice up here, I've got track changes on. I am now in the other container. Take a look at Docker PS. We see our web and our API container are both here. So if we think about that through Visual Studio using Docker commands, Docker files, and the Visual Studio experience, I'm able to debug two completely separate containers. In this case, they're Linux containers from my Windows machine, and I can debug across both processes. So that's pretty cool. Now let's take a look at what this looks like for .NET Framework. We'll switch over to Windows containers. We'll create a new web forms project, and we'll call this NetFX. And we'll use web forms, right? How traditional is that? And so the idea is you can take your existing projects, your existing .NET Framework projects that you've been working on for years, maybe a decade, and you want to be able to move that into a container for the DevOps workflows. So you're going to take your existing app, add Docker support. We will add the Docker file, which loads ASP.NET Runtime. This is based on Windows Server Core. You'll notice that we're actually using IIS, the www root directory, and you'll notice that there's no entry point because the entry point is IIS. So now I can start my experience. You'll notice the Docker file is there. We have our Docker Compose file here for instancing our container. And then the Visual Studio unique configurations we've separated out in our debug YAML file. So we'll let it build that. If we come over here and say Docker images, we can see our ASP.NET image based on Windows Server Core, and here's the NetFX image that we're building at this point. So let that finish building. And now we have our Web Forms app running in a container. And again, we could come over here and we can make a change. So we'll say in a container again. We can refresh that. So there's our change. And of course, we can set breakpoints as well. And we'll just pop one right here, hit about, and now we're in the debugger. Hopefully that gives you a good overview of the capabilities of Visual Studio Container Tools. We support .NET Framework and Windows Server Core, enabling your first step of running your existing apps in containers, which gets you on the first steps towards a microservices architecture. And .NET Core in Linux containers, where you can build out new services. Nano Container Tooling is coming soon to round out this matrix of options. With that, I'll let you get started with containers and continue your productivity while becoming a Docker developer. Thank you.